Hello and welcome. Today we are tackling a question that, on the surface, seems incredibly simple. But, as we're about to see, the answer is anything but. And getting it wrong, well, that has multi-billion-dollar consequences.
Here it is. Are patients actually taking their medication? I mean, it sounds easy enough, right? Your doctor writes a prescription, you take the pills, you feel better. But is that really what's happening? The answer to that question impacts everything from your personal health right up to national healthcare policy.
And when I say it has an impact, I mean a huge one. In the United States alone, the estimated annual cost of unused medications can climb as high as $5.4 billion. That is just a staggering amount of waste, and it's all tied to not having a clear answer to that one simple question.
So yeah, this is way more than just a little clinical curiosity. We're talking about a multi-billion-dollar question. Answering it the right way could save an incredible amount of money and, way more importantly, improve health for millions of people.
So, to try and get an answer, the healthcare industry came up with a standard metric. It's called the proportion of days covered, or PDC for short. The formula is pretty basic. You just calculate how many days a patient had their medicine on hand, and you divide it by the total number of days you're looking at. A high score means they're doing a good job. Seems straightforward, doesn't it?
Well, here's where things start to get really interesting. That simple math, it completely depends on when you decide to start and stop the clock. Because you see, getting a prescription isn't just a single event. It's actually a whole journey.
And if we can understand this journey, we can start to see why our simple question is actually so tricky to answer. So let's break that timeline down.
So, a prescription basically has three key moments in its life. First, the doctor writes it. That's the moment of intent. Second, the pharmacy fills it. That's when they do all the processing and insurance stuff. And third, it's sold. That's the moment you, the patient, actually walk in and pick it up. Three totally distinct points in time.
You can really picture the whole process here. You've got the doctor's office, then the pharmacy's back office, and finally the patient's action. Each one of these steps creates a totally different data point, a different timestamp. And the crucial thing to understand is that there can be some pretty big delays between each of these steps.
Now, check this out. What's really fascinating is how different those delays are. Just look at the chart on the left. That's the fill lag, so the time between the doctor writing the prescription and the pharmacy filling it. Now look over at the chart on the right. That's the sold lag, the time from when it's filled to when you pick it up. See how different those curves look? And let's put some hard numbers on that. It turns out 90% of prescriptions are picked up within just 3 days of being filled. That's really quick. And this is a big but, it can take up to 29 days for 90% of those same prescriptions to even get filled after being written. That huge gap tells us that a lot of the delay isn't just the patient, it's system friction. Things like waiting on insurance approvals or pharmacy backlogs. So, if we have all these different timestamps and all these potential delays, which one do we actually use to measure adherence? Well, this leads us to the real heart of the matter. There are two very different ways to run the numbers, and they tell two very different stories. Okay, so on one side, you've got something called exposure PDC. You can think of this as the raw, totally unfiltered number. It just looks at the total time from the very first prescription to the last one and counts any day you don't have the meds as a failure. Simple. On the other side, you have adherence PDC. This one's a bit more refined. It looks at a patient's own history to figure out if a long gap is a real stop in therapy, and it adjusts the math to account for that. Here's a really easy way to get your head around it. Imagine you're measuring a student's attendance. Exposure PDC is like measuring their attendance for the entire calendar year, including weekends and, summer break. It's not a very useful number. Adherence PDC is smarter. It pauses the clock during summer break and only measures attendance when school is actually in session. One is a raw measure of time, the other is a measure of consistency when it actually matters. So, what happens when you take these two different lenses and apply them to the very same set of data? Well, this is where the story takes a pretty dramatic turn. Just how dramatic? Get this. Over 15% of patients get reclassified. They go from being adherent to non-adherent simply by switching which data point you use as the starting line for that raw exposure PDC method. That is a massive swing based on one tiny choice in the data. And you can see it happen right here. Look at the diagram on the left. That's adherence PDC. See how the blue bars, the adherent patients, stay overwhelmingly blue? It's stable. Now, look at the right, at exposure PDC. Do you see that huge river of red that starts pouring out of the blue bar when you switch from the fill date to the written date? That's it. That's our 15% of patients being reclassified right before our eyes. The whole picture just flips.
Let's just boil this down with a simple chart, because the difference is, well, it's kind of nuts. If we use the written date as our starting point, the smarter adherence PDC method says a whopping 99% of patients are adherent. But the raw exposure PDC method? It says only 42% are. I mean, come on. It's the same patients, the same exact data, but we get two completely different realities based on the math we choose.
Right now, you might be thinking, okay, that's a cool data puzzle, but why does this really matter in the real world? The answer is, it matters an incredible amount. It has real-world consequences for everyone, from your local doctor's office all the way up to the government.
I think this quote from the research paper just says it perfectly. Adherence isn't some fixed, objective truth just sitting out there. It's an interpretation. It's a story we tell with data. And that story is shaped entirely by the data source we choose and the lens we use to look at it. And that story has massive downstream effects. For example, your doctor might see a low adherence score and decide to switch your medication, thinking you aren't taking it, when the real problem is just a lag in the data. A hospital's quality rating, which affects their funding, can go up or down based on this one choice. It shapes policy, it decides which patients get a follow-up call from the pharmacy, it fundamentally changes how we see you as a patient.
So, at the end of the day, the crucial point is this. When we're trying to measure something as messy and as human as behavior, understanding the biases and the limits of our tools isn't just a nice-to-have, it's everything. Choosing the right lens can be the difference between seeing a clear picture and seeing a dangerously distorted one.
Which kind of leaves us with one final thought to chew on. If data can tell such radically different stories about something as seemingly simple as taking a pill, what other stories is it telling about us every single day with all the data we generate? And more importantly, are we sure we're using the right lens?